So we change this one to a is less than 0. So first of all, so the very first thing I'm going to look at when I look at this, how many x's do I have? No, I have 2 here and 1 more, so that's 3, right? So if it's x to the third, the end behavior is this and this. But if I change the a so it's negative, the end behavior has to go the other way. Up and down. So even without thinking about that, the next thing that I would ask myself, if I have a 2 right here, the 2 tells me it doesn't go through the axis, it's a touch. There's only one of them that has a touch. D. It had to be D. And it is D. The end behavior matches. It's a touch here, and it goes through the axis, so it had to be D. Okay, number 2. Shh. Hey, y'all, be quiet. Number 2. First of all, I can't factor this because it has the x third. Okay, y'all, stop the individual conversations. It's all about me now. So w to the third minus 9w, I have a w in common. And the w squared minus 9 factors. So if I set each of these equal to 0, I get w equals 0, negative 3, and positive 3, which is a. Number 3, it says use long division. So let me ask you, if you did synthetic division, do you get the same answer? Yes. You do, on this one. When would I not get the same answer? If this was like 2x minus 3, you have to use long division. If it's just x minus 3, you can use synthetic division and get the same answer. Anyway, you get D. How many of you got it? So everybody's okay on that? All right. So for number 4, first of all, for number 4, they are. So what do you think that's a hint that it is? Those are not correct answers, right? So just looking at this, first of all, it's a touch here, right? If it's a touch at this point at 2, then what do I have to have for an exponent? I have to have squared. And did I move to the right or to the left? This one is a positive 2, so my x has to lie. So it's got to be x minus 2, so it's one of these, right? So then, no, because if you multiply it out, you would get a positive 3. But so the next thing I'm going to look at is both of these give me a negative 1 here, right? So that's correct. So the only difference between this is negative and this is positive. So what's the end behavior? Should it be a positive or a negative? It's a positive, so the answer is C. Okay, number 5 is an example of a problem that probably you would miss if we didn't go over it, but it's an example where it's easy. So first of all, x to the third is an example of an odd function. So I want you to think about the graph y equals x to the third. It is an odd function, but what point does it go through? It goes through 0, 0, correct? That's the only point that it goes through, right off on the graph, exactly. So the question asks, Which of the following transformations allows the function to retain its odd symmetry? Which means no matter what you do, it still goes through 0, 0. So if I add k, which way does that shift the graph? To the left and amount, right? Does that go through 0, 0? No. The plus k, what does that do to the graph? Up. So is that through 0, 0? If I multiply by a constant, it still goes through 0, 0. That's the only option. It's 3 only. You want to pick the one that allows it to stay to going through 0, 0.
Where should I go for math time?
What do you think number 6 is? B is correct. Why is it not x equals negative 2? What's the difference between y equals negative 2 and x equals negative 2? Which way does y equals negative 2 go? This way, which means that the graph either hugs it above or below and stays at negative 2 then. X equals negative 2 is up and down, and it doesn't give you a y answer then. So it has to be B. Okay, number 7 is a pretty difficult one. Yes. So inverse means you switch the x and the y. So how do I get rid of a cubic? I have to cube both sides. So I get x minus 2 to the third, which is D. Number 8. Of the 3 functions shown, which are neither odd nor even? So what's number 1? That's even because you can fold it around the y-axis. What's number 3? Origin, and it goes through the 0, 0. So that's odd. So what about 2? Can I fold that around the y-axis? Does it go through the origin? So this is neither. Okay, number 9. First of all, what's the degree here, guys? How many x's? 5, which makes it odd, correct? So if it's odd, the end behavior should be this way. But wait, what's the A? It is? Really? Right here? So then the end behavior has to go like this.
That's what I was thinking too, Miss.
Thanks. Appreciate that.
You're welcome.
So which one does it have to be?
6.
Okay. Number 10 is pretty difficult. There's the tangent of theta. What is tangent? Opposite over adjacent.
That's what I couldn't remember.
You're going to fail, Isaac. So you're going to get 8 over 6, and I know it's pretty hard to reduce with your head to 4 over 3, which gives you B. Number 11. Find the indicated limit for the function. Okay. You guys, stop talking. So first of all, this is asking for the limit as x goes to -3. So here's my negative 3. This is where the asymptote is, but it wants it from the negative side. So coming from the negative side, what does your y value go to? It goes to infinity. What would the answer have been if I went to negative 3 from the positive side? Negative infinity. Does the limit exist there? Why? They don't match, so they don't exist. Number 12. Which of the following statements are true? F is increasing from negative 6 to negative 4. So from negative 6, which is here, to negative 4, does that function increase? All right, so that's true. F has 2 zeros. Is that true or false? That is not true. F is decreasing from negative 2 to 0. Is that true? So it's this one only. What's number 13?
Is it right here?
Okay, so
It has to be.
So f of x plus 2 is going to go on the bottom. So my f of x equals 1 over x plus 2. So what can the denominator not equal? I can put 0 in there. 0 plus 2 is okay. So x can't be negative 2 because that makes a vertical asymptote. Which is the only one that has a vertical asymptote at negative 2? A.